friends, I am Vikas. Welcome to my YouTube channel. This is the second video in continuation of the learning series about generics. So in the previous video, we learned about what generics are and how generics are useful to us and how can we create custom types with the help of generics and how can we use protocols to achieve generics with the help of associated types. So if you want to learn about all these, so please check my previous video of this learning series, so you will learn about all these. So in the today's video we are going to cover how can we apply constraints on the generics and what are the different ways of applying constraints and how they are helpful to us. And in the next we will cover about the difference between generics and opaque types versus the existential types. So you will see in the coming videos, and at the end we are going to cover some interview questions. As we know, this is one of the hot topic in the interviews, so I'm pretty sure after watching this series you will able to answer all the questions. So let's start. It is sometimes useful to enforce certain type of constraint on the types that we have used for the generic function and the generic types. It also improves our code a bit. Like, how can we apply constraints? So we are applying constraints by inheriting from a specific class or conform to a particular protocol or the protocol composition. Like in the dictionary, Apple provided dictionary, the keys are always conformed to the hashable protocol. So no matter, the key can be of any type, but it must conform to the hashable protocol. If you didn't get much about it, so don't worry. We are now going to learn more with the help of implementation. So for implementation, I created one container type protocol. So the protocol has associated type item and items array that hold the specific type of items, and append function to append the items in the array, and count, it will return the count of the items in the container. And I have created one struct which conforms to this container type protocol. So these are the methods we have implemented for append to append an item in the array, and the count, it is returning the count of the container items. So now suppose if I need to extend the functionality of this container, I need to add a new method for finding the index of an item in the array. How should I do it? So I will create one extension and extension of this container and add a new method within the extension. So let's do it. Extension container and create one function, find index of value to find, and it should return end. We can make it optional as it might return nil as well. So for index value in items dot enumerated, if value equal to value to find, return index. If we found the item, so we are returning index, else we need to return null. Okay, so now we start getting an error because T doesn't know anything about double equal to operator. So how can we do? So this is the equality operator. So we can resolve this error by confirming the item with a equitable protocol. So now we need to implement here as well. So now this error should away. Yes. So now we have applied constraint on the associated type item. So the item must conform to the equitable protocol to satisfy this functionality. Okay. So the other way of doing this is we should remove here, and we can use it the where clause, where t is of type equitable. So this should also work fine. So we applied the constraint on the extension. The t should be conformed to the equitable protocol. This is called contextual where clause as well. So now there is one more way to do this. We can apply the where condition by in the method declaration. So now this method is only available when t conforms to the equitable protocol. To test this, let's call this function from the object, and here we have the container object, find index of 2, and let store in some constant and print that constant. So this should work fine. So it is giving us warning to handle the optional value as it is returning the optional. So let's not bother about this for now and move on. So next, if what if we need to extend the functionality of the container and need to add one more function of finding the maximum value within the container, like we have the max function in the array. So let's create one more extension. And I have already written the code of finding the maximum value from the container. So let's copy paste. So it saves our time. So this function is the max. It's returning the optional value. If the item count is less than 0, it is simply return nil. And we have created one variable and initialized with the first object in the container. And after iterating the loop, we are finding the maximum value and returning the maximum value from here. So we started getting an error. D doesn't know about the binary operator. So as we know, the binary operators are part of the comparable protocol. So let's fix it. How can we do? We can fix it by simply writing the where clause like we did for the equitable in the find index method. So let's copy paste it here, and instead of equitable, let's do comparable. So this should work fine. The another way of doing is we can simply write while writing the extension. So this should also work fine. Let's remove it from here. And another way, we can create the protocol composition to so we can restrict the associated type to conform to the equitable and comparable protocol. Like in this way, let's create one protocol composition, constraint type, comparable and equitable. So we know comparable is already conforming to the equitable protocol. Like just for demonstrating, so I'm writing the protocol composition, so we can see the comparable is already conforming to the equitable. So for demonstrating, I have just created the protocol composition. So let's associated type conform to the constraint type, and we can define here as well. So now this doesn't require anymore. So this should work fine as well. So we can define constraint from the protocol composition as well. So instead of creating the separate extensions, we can keep the code in a single extension as well. Let's copy paste it here, and we do not require anymore. So we seen here how can we apply constraint to the associated types by conforming to some protocols. Now make it more restrictor. We will restrict our associated types to the specific type. So let's create one more extension which we are going to restrict for the specific type. And in the extension, we are going to write the find average function. So we know that we can find the average only if we have int in the containers, right? So we can't able to find the average if we have string items in the container. So to demonstrate this, let's create one more extension, container, and I have I have the code written with me to for finding the average. So let's copy paste that code. Where is that code? Yes, here it is. So this function is finding the average of the container items, and here we have the variable sum, and we are calculating the sum of all the items and calculating the average. Okay, so we know uh, if we know we can calculate the average only for the int items, so we can restrict it by applying the where clause here, where t double equal to int. So now we should not get any error. So yes, so we restricted this function only when t is of type int. To demonstrate this, let's call this function from container. So as this is an array of int, right? So let's call find average. We can access this function. So now let's create one more container that store strings value. Okay, let's copy paste it here and name it animals, and instead of int say cat, dog, rat, rabbit, lion. So when we try to access this from animal container, so we cannot access this find average. Okay, so we restricted this function only for when t is of type int. Okay, so now let's move on to cover one more concept. Let's create one more function of merging the two containers. So two containers can only be merged if they are of the same type. So let's write one function merge. Let's get two containers and define the types. Container 1 is of container type, container 2 is of container type C1, type container 1, and C2 is of type container 2. And we need to apply the where clause, as we are defining the requirement two containers can be merged if they contain the same type of items. So let's define the constraint here, where container 1 dot items container 2 dot item. Okay, so we define the constraint here if container 1 item is equal to the container 2 item. So now let's write code to merge the two containers. So let's create one array, or say merged array is of type container1 dot dot item. It should be of this type, right? As we applied the constraint, so both containers have the same type of items. So I created so the array which is of container1 dot item type. So now I iterate over the container1 items in c1 dot items merged array dot append I. Similarly for the c2 items. Now let's return some container. So let's create some container object which is the merged container, right? So container, and we have provided the merged array. Okay, and let's return container, and we need to define the return type here as well. So we can write like these two items are of the same type, so we can return, so return the container1 dot item. We can return container1. Does it make any sense? So we are getting an error, cannot convert return expression container1 item to the container1. So or let's try to return container type from here. Still we will get an error. So yeah, so it is saying the container type as a type must be written any container type. So let's fix it. And what is this any keyword? This is called existential type. So we are going to cover in the next video. So what existential and the opaque types are. So to test this, let's create object, whether it is working fine or not. So here we have one container object. So let's create another object, container1, which has 6, 7, 8, 9, and 10. So call the merge function, merge c1 and c2. Here we have container and container1. Let's print this as well. So we have seen now this is working fine. The items got merged. So in this video, we learned how to apply the constraint on the associated types or on the extensions or on the functions, and how to restrict the implementer to follow that requirement. So as we seen, we have applied constraint through protocol or the protocol composition or through the contextual where clause. So that's it for this video. Thank you for watching and see you in the next video. Thanks.